Hi everybody, welcome back. This is Esther here. How are you all doing? I hope you all are doing great and well during this pandemic. Today we shall be starting with intro to exercise 6.2. In the previous video, we saw the complete exercise 6.1. Today we will be starting the intro to the next exercise. So it's going to be a bit lengthy, honestly. Okay, but don't be scared that, oh, it's going to be so lengthy and hard. But I'm trying to make things simple for you so that you won't struggle. So don't worry, we shall take care of it. Okay, so it's going to be very interesting. We're going to be learning lots of new things, and we'll be learning a couple of axioms and theorems. In the previous video we saw axiom 1 and 2 and theorem 1, but in this video we will see axiom 3, 4, theorem 2, 3, 4, 5, 6 as well. So I know there's quite a lot of things, but just try to understand. If you're not able to understand, let me know in the comments and try to rewind the video and listen to it again. Okay, and I'll try to make a strategy to help you to remember the axioms and theorems. Once we finish learning all the axioms and theorems, I'll make a strategy for you so that you will be able to easily learn it, because I learned all the theorems and axioms through that method. So hopefully it helps you out as well. Okay, so with this short note, let's start with this video. Okay, so the very first thing that we're going to be seeing is parallel lines and a transversal. Okay, parallel lines and a transversal. So you know what are parallel lines? These two are parallel lines, correct? I know it doesn't look straight like a line, but pardon me, I cannot do anything because it's not a notebook or something like that. It's a virtual screen, right? Yeah. So now, what is a transversal? The line that connects both these parallel lines at distinct points. That is called as a transversal, correct? So one second, let me try to construct a proper transversal. I don't know why it just keeps like going bad. Okay, anyways, try to adjust with this. Okay guys, so sorry, but just try to adjust with this. So I'm gonna ask you a question. How many angles will be formed here, here, and here? Let me give you a clue. Now tell me how many angles can be formed here. I know you have learned parallel lines in a transversal last year also, right? Yeah, from 7th standard you have been learning parallel lines and transversal. Yes, there are going to be 8 angles. Let me name them with a different ink. Sorry. Yeah, with a different ink. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 8 angles are formed here. So in two parallel lines, 8 angles are formed. 8 angles are formed. By the way, it's not just 2 parallel lines. Okay. 2 parallel lines and a transversal. 2 parallel lines and a transversal, 8 angles are formed. And by the way, if you're looking at this and you're thinking, what is this? Let me tell you, this means parallel. So if I'm ever using this symbol, that means that I'm saying that the given things or the given lines are parallel. Okay, the short form for writing parallel. So probably your teachers could use this, or in your question paper also. Maybe if the examiner wants or Cbse board wants, they could give this symbol, but you should know that this symbol means parallel. Okay, so now we shall be studying about the different types of angles that are formed with respect to parallel lines and a transversal. So let's see. Let's take this transversal to be transversal L, these two parallel lines to be M and N. Okay, so let's see the different types of angles. Are you all excited? Okay, even if you aren't excited, get ready because we're going to dive into a deep concept. Now, exterior angles. What are exterior angles? The lines which are basically outside the transversal, outside the parallel lines, meaning angle 1, sorry, here 2 came, but anyways, angle 1 and angle 2 and angle 7 and angle 8. That means these two angles and these two angles. They're outside the transversal, outside the parallel line. So we call them as exterior angles. Now the angles which are inside the transversal, inside the parallel lines, are called as interior angles. They're inside. We call them as interior angles. Fine. So what are the interior angles here? Angle 3, angle 4, angle 5, and angle 6. These are interior angles. So I hope interior angles and exterior angles are cleared. Fine. So now let's look on to what are corresponding angles. Corresponding angles. You probably might hear this term from now on very often in your questions and theorems and all of that. So you must be clear with the types of angles. See, maybe on the first time, you might not understand what are the types of angles, but as you keep revising these angles and you solve more word problems and all of that, you will understand and you will be able to remember what are the different types of angles. As you keep solving, you will improve in that. So don't worry about that. So what are corresponding angles basically? Now let's see what are corresponding angles. In this case, angle 1 and angle 5 are corresponding angles. Okay, angle 1 and angle 5 are corresponding angles. Angle 2 and angle 6 are corresponding angles. Then what else? Angle 4 and angle 8. Then, okay, one sec. Yeah. And then angle 3 and angle 7. Now look here, what is this angle 5 and angle 1, angle 2 and angle 6? What am I talking about? That means that angle 1 and angle 5 are one pair. So this is the first pair, okay? Second pair is angle 2 and angle 6. Third pair is angle 4 and angle 8. And the fourth pair is angle 3 and angle 7. Okay, so these two are pairs. Then these two are also pairs. These two are pairs. These two are pairs. Okay, so each of these pairs are corresponding angles. Fine. And corresponding angles are equal to each other, meaning like if in this pair, if you see angle 1 and angle 1 is equal to angle 5 because it's a corresponding angle. Okay, remember that, because like in problems, again, it's going to be absolutely useful. Fine. So now you understood what is corresponding angle? Okay, good. Now we shall be seeing what are alternate interior angles. Okay, what are alternate interior angles? So let me just clear up this figure a bit. Quite dirty, isn't it? Sure, fine. What are alternate interior angles? I'll tell you what are the pairs of alternate interior angles in this figure. Angle 4 and angle 6 are one pair. Angle 3 and angle 5 are one pair, meaning if this is my transversal and I have like two parallel lines here, that means this angle and this angle are alternate interior angles. Similarly, this angle and this angle are alternate interior angles. Okay, in the inside in the interior, the alternate angles inside the transversal, basically, I mean inside the parallel lines. Okay, So these are called as alternate interior angles, or you can say interior alternate angles. Interior alternate angles as well, you can say that. So by the way, don't get confused, this means alt and this means angles. Okay, I'm writing the like meaning of everything so that you don't misunderstand things. So okay, so in this case, angle 4 and angle 6 are one pair, alternate interior angles pair. Angle 3 and angle 5 are one pair, alternate interior angles pair, that is. Okay, so now alternate interior angles are clear, I hope. Now let's say alternate exterior angles. These are what is interior. Now let's see what is exterior angles. Yeah, alternate exterior angles. Same thing, nothing different. Same thing. See, now let's take again. I'm drawing it separately so that it would be easier. See, alternate exterior angles. That means we are talking about exterior angles definitely. And that means these two, this one and this one. Here in this case, this is angle 1, angle 2, angle 8 and angle 7. So that means angle 1 and angle 7 are alternate exterior angles, whereas angle 2 and angle 8 are another pair, alternate exterior angles. In the exterior side, we have alternate angles. That's all. Okay, so angle 2 and angle 8 are alternate exterior angles. Okay, so if you are not able to understand, you're not able to keep up, then after you finish listening to this whole video, you can like make down quick notes, and you can note down whatever we've studied, and you can write it down and try revising it daily so that it'll be easier, and keep solving the textbook exercises and examples and more extra questions as well. Okay, so that things will become more easier. So now coming back, last, that's it. Okay, last, so that is interior angles. So let me not write angles like this. Let me just write plain old angles. Interior angles on the same side of the transversal. What is this? Interior angles on the same side of the transversal. We call this as interior angles on the same side of transversal, or we call it as co-interior angles. Co-interior angles, or we also call it as allied angles. Allied angles. So this has three names, but I feel for your understanding right now, the first one would be more comfortable, correct? Yeah, so interior angles on the same side of the transversal. Now we are completely focusing on interior angles on the same side of the transversal. So that means here we're talking about the interior angles on the same side of the transversal. That means in this case, let's take the left hand side, angle 4 and angle 5. So these two are one pair. Angle 4 and angle 5 are interior angles on the same side of the transversal. Similarly, angle 3 and angle 6 as well. Angle 3 and angle 6 are what? Interior angles on the same side of the transversal. And remember always, interior angles on the same side of the transversal are supplementary. That means angle 4 plus angle 5 will be equal to 180 degrees. Similarly, angle 3 plus angle 6 will be equal to 180 degrees. Remember that always. And anyways, we will be coming across that in our theorems as well. So no worries. So we shall be seeing about that. So that's all about parallel lines and transversal. Finally, we have completed what are parallel lines and a transversal, right? And what are the different types of angles? Hope it was clear. Now we shall be seeing the third axiom now. So let's see, what is this third axiom? If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. So I have two parallel lines. And according to the statement, if a transversal intersects two parallel lines, then each pair of corresponding angles means this one and this one, then this one and this one, then this one, and then this one and this one. So if there is a transversal, let's say transversal L intersects two parallel lines M and N, then each pair of corresponding angles are equal to each other. That's what axiom number 3 states. Hope it's clear. So by the way, let me just tell you what are this, since you just now learned what are corresponding angles. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. That means angle 1 will be equal to angle 5, angle 4 will be equal to angle 8, angle 2 will be equal to angle 6, and angle 3 is equal to angle 7. If a transversal intersects two parallel lines, then each of these are equal to each other. Now, axiom 4 tells us that if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. Again, we have a transversal L, two parallel lines M and N. So they're saying that if a transversal L intersects two parallel lines M and N, then each pair of alternate interior angles means this one, and then this one and this one. They are alternate interior angles. So that means if I have to name this, that means angle 4 will be equal to angle 6, angle 3 is equal to angle 5. So if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal to each other. This is axiom 4. So hope axiom 3 and axiom 4 were clear to you. Moving on to theorem number 2. Okay, so let's see what is this theorem number 2. So theorem 2 says, if a transversal intersects two parallel lines, then each pair of alternate interior angles are equal. So now we have to actually prove this theorem. Okay, so to prove. So let's first draw our parallel lines, transversal angles and all. Yeah. So we have, let's say transversal T. We have two parallel lines AB and CD. Angles, let's name angles 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So what do we have to prove here? What do we have to prove? We have to prove that alternate interior angles are equal. That means angle 3 is equal to angle 5 and angle 4 is equal to angle 6. So if this transversal T intersects two parallel lines AB and CD, then each pair of alternate interior angles are equal. In this case, angle 3 will be equal to angle 5 and angle 4 will be equal to angle 6. Okay. So let's see how to prove this. Now look here. We know that angle 3 is equal to angle 1. Meaning this angle 3, when I'm talking about the angles and lines, parallel lines, okay, all of this, make sure to look at the figure. Look at the figure when I'm talking. Okay, that's when you can understand. So now we know that angle 3 is equal to angle 1. Why? Because they are vertically opposite angles. And we know that angle 1 is equal to angle 5. Why? Corresponding angles, right? Angle 1 is equal to angle 5, correct? So now, can I therefore say that angle 3 is equal to angle 5? Now, where did angle 3 is equal to angle 5 come? See, if angle 3 is equal to angle 1 and angle 1 is equal to angle 5, can I substitute angle 3 in the place of 1 here? So therefore, angle 3 is equal to angle 5, correct? That's how I got it. Okay, now we've got this. Now we also know that angle 4 is equal to angle 2. Angle 4 is equal to angle 2. How? Again, vertically opposite angle. And angle 2 is equal to angle 6. Angle 2 is equal to angle 6, which is corresponding angles. Okay, corresponding angles. So therefore, angle 4 is equal to angle 6. Correct? Angle 4 is equal to angle 6. So here, angle 4 is equal to angle 2. Angle 2 is equal to angle 6. We are substituting the value of 4 instead of 2. So therefore, angle 4 is equal to angle 6. Thus proved. Over. You understood what we had to prove. Angle 3 is equal to angle 5 and angle 4 is equal to angle 6. That's what we have proved here, right? That's proved. Easy, simple. First we said that angle 3 is equal to angle 1. Then angle 1 is equal to angle 5. Substituted the values. Angle 3 is equal to angle 5. Similarly, angle 4 is equal to angle 2. Angle 2 is equal to angle 6. Angle 4 is equal to angle 6. So that's proved. Easy. I think this theorem was one of the easiest, right? I know. So now let's see what is theorem number 3. So theorem number 3 tells us that if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So let's just draw the figure. We have a transversal, two parallel lines. So if a transversal intersects two parallel lines, transversal L intersects two parallel lines M and N. By the way, they haven't said that if a transversal intersects two parallel lines, they've just said that it's two lines. They haven't said parallel lines. So now referring back to the statement, if a transversal intersects two lines such that a pair of alternate interior angles are equal, that means if these two angles are equal plus these two angles are equal, then we can say that these two lines are parallel. That means M and M are parallel in this case. So let's see how to prove this statement. Proof. And by the way, this is actually a converse of theorem 2. What is converse? Converse means opposite. So this theorem 3 is actually an opposite of theorem 2. What did we see in theorem 2? If a transversal intersects two parallel lines, in each pair of alternate interior angles are equal. Now they're saying if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Okay, so it's a converse of theorem 2. Okay, so now let's see what is given. So that's given that angle 3 is equal to angle 5 because alternate interior angles, let's name it so that it's much more easier. 1, 2, 3, 4, 5, 6, 7, 8. So angle 3 is equal to angle 5. Yeah, alternate interior angles, alternate interior angles. Now we need to prove that what AB is parallel to CD, correct? We need to prove that AB is parallel to CD. So let's see the proof to that. Fine. So what is the proof? We have also that angle 3 is equal to angle 5, which is given, plus angle 3 is equal to angle 1. How? Vertically opposite angles. Correct? Vertically opposite angles. So therefore, can I substitute the value of 1 instead of 3 and just say angle 1 is equal to angle 5? Yeah. Okay, so from this we can say that angle 1 is equal to angle 5. But as you can see that angle 1 and angle 5 are corresponding angles, correct? Look in the figure. Angle 1 and angle 5 are corresponding angles, right? So let's write that. But angle 1 and angle 5 are corresponding angles. So since they're corresponding angles, we can say that AB is parallel to CD, correct? AB is parallel to CD. How? By corresponding angles, axiom. It's a truth, right? So by corresponding angles, axiom, we can say that AB is parallel to CD. Ayo, here it is not AB, right? Oh, so sorry. I'm so sorry. I'll name it again properly. It's not line M and N. Pardon me. It is lines A, B, and CD. Yeah, that's what you were thinking, right? What is she telling? AB is parallel to CD. Now AB is parallel to CD by corresponding angles, axioms. Thus, we have proved it. Thus proved. Understood what we did first. We said that angle 3 is equal to angle 5, alternate interior angles, which is given actually. And then we wrote what we have to prove, and then we started proving that. So we told that angle 3 is equal to angle 5, and angle 3 is equal to angle 1 because it's a vertically opposite angle. So therefore angle 1 is equal to angle 5. But we also know that angle 1 is equal to angle 5 because they're corresponding angles. So therefore AB is parallel to CD by corresponding angles axiom. Now look here, you might be having a question that why didn't I prove that angle 4 is equal to angle 6? Why did I just prove only angle 3 is equal to angle 5? And why did I just prove that angle 1 is equal to angle 5? And why couldn't I have proved that angle 2 is equal to angle 6 as well? Yeah, corresponding angles. Because in the statement they say that if a transversal intersects two lines such that a pair of, only a pair, not each pair of. Okay, so I only need to prove that a pair of alternate interior angles are equal, right? So therefore here if I say that by corresponding angles axiom AB is parallel to CD, then why do I need to prove again that angle 2 is equal to angle 6 because angle 4 is equal to angle 6, and then by going with vertically opposite angles, etc. and all. Why do I need to do all of that stuff? Because I've already proved that by corresponding angles axiom, AB is parallel to CD. That's why I didn't do that. Okay, so this is theorem number 3. Moving on to theorem number 4. So now we have theorem 4, which let's just tell here like what's happening. So if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Let's draw it first. Transversal, two parallel lines AB, CD, and we have transversal D, 8 angles. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have all these angles. So what are they saying? If this transversal T intersects two parallel lines AB and CD, then each pair of interior angles on the same side of the transversal is supplementary. That means angle 3 and angle 6, when we add angle 3 and angle 6, we will get 180 degrees. That's what it means, right? Interior angles on the same side of the transversal is supplementary. I told you earlier while teaching you what are interior angles on the same side of the transversal. I told you they were supplementary, correct? So here, similarly, angle 4 plus angle 5 is equal to 180 degrees. That's what it tells us. Now we shall see what we have to prove, what is to prove, what is the proof, given everything. Now, given that AB is parallel to CD. Yeah, AB is parallel to CD. And we have interior angles, angle 3, angle 6, and angle 4 and angle 5. I mean interior angles on the same side of the transversal. Instead of writing such a big statement, you can just write co-interior angles, finished. So you can write that in exam. Anyways, I'll just write it for now. Interior angles on the same side of the transpose. Fine. Now what is to prove here? To prove angle 3 plus angle 6 is equal to 180 degrees. And angle 4 plus angle 5 is equal to 180 degrees, right? So now we wrote what is given, what is to prove. Now let's see the proof to this. So the proof is, we know that so now let's take a ray EF to stand on line AB. Okay, so that means, see, let's say this is point E and let's say this is point F. Okay, so let's say that ray EF stands on AB. Okay, AB, line AB. Okay, and now we know that angle 3 plus angle 4 is equal to 180 degrees. How is that? Linear pair, yeah. But we also know that angle 4 is equal to angle 6. Angle 4 is equal to angle 6, correct? Why? Alternate interior angles. Alternate interior angles. So therefore, what can we say? Since angle 4 is equal to angle 6, can I substitute angle 6 in the place of angle 4 in this equation? Let's say this is equation 1. Can we say that we can substitute that? Absolutely. So angle 3 plus angle 6 is equal to 180 degrees. Correct? What did I do? I said that angle 3 plus angle 4 is equal to 180 degrees because it's a linear pair, and angle 4 is equal to angle 6 because it's alternate interior angles. So therefore, can I say from this one, let's say this is equation 2, from equation 2, can I say that angle 4 is equal to angle 6, and therefore in equation 1, can I substitute angle 6 instead of 4 from equation 2? Absolutely, I can do that, correct? So this is how I got angle 3 plus angle 6 is equal to 180 degrees. Now, again, FE, okay, ray FE stands on CD, line CD. So we have angle 6 plus angle 5 is equal to 180 degrees. Again, because it's a linear pair. And angle 6 is equal to angle 4, alternate interior angles. So therefore, let's say this is equation 3 and equation 4. From equation 4, can I say that angle 4 plus angle 5 is equal to 180 degrees? Meaning, since I know that angle 6 is equal to angle 4, can I substitute angle 4 instead of angle 6? Can I do that? Yeah. So angle 4 plus angle 5 is equal to 180 degrees. Okay. Fine. Understood till here. So now we have proved that angle 3 plus angle 6 is equal to 180 degrees, and angle 4 plus angle 5 is equal to 180 degrees. And that's exactly what we have been told to do, correct, from here. So thus we have proved. Yeah, right. We had to prove angle 4 plus angle 5 is equal to 180 degrees and angle 3 plus angle 6 is equal to 180 degrees. That's what we have done. Finished proving. So I hope it was clear to you that how we, proved it. So now we finished theorem 4. Let's move on to theorem 5. I know this is going on for a pretty long time right now, but excuse me, please forgive me. I have no clue on, like why there are so many theorems, but we have to learn it because it's there in the syllabus, right? So don't take it as a burden. It might be boring, I know, but just try to cope up, right? Because it would become interesting if you try to understand, right? Only if you put your interest and try to understand that if you think that, what's so big in this? Is it such a big thing and such a big, what do you say, such a big rock or such a big mountain to understand about? Absolutely no. Let me put in some interest and try to understand. And guys, I can tell you that surely you will be able to understand. Okay, so if you feel you need a break, or you feel like it's too much, break it into bits. Today you listen to up till whatever theorem you want, and tomorrow you continue, then do a revision on day 3, right? Take it in bits if you're not able to digest it completely. Fine. So now let us see theorem number 5. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So, of course, our diagram, CD, and then we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have our figure. So they're saying that if a transversal T intersects two lines, that is two lines of what? AB and CD, such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Again, this is the converse of theorem 4. So what do we have to prove here? First, let's write what is given. Given that angle 4 plus angle 5 is equal to 180 degrees. And we need to prove that AB is parallel to CD, right? AB is parallel to CD. So let's see the proof to it then. We know that, okay, so let's take now ray EB stands here. Okay, let me just draw that for you. Now, let's say we have a point E here. Okay, let's say that we have a point E here. Now, let's say EB is here. So now since we have EB, so let's say EB stands here on this line E. Okay, it stands here on this line E. Stands on line E. Okay, let's say it stands on line E. Now we know that angle 1 plus angle 4 is equal to 180 degrees. How? Because it's a linear pair, correct? And we also know that angle 4 plus angle 5 is equal to 180 degrees because co-interior angles are supplementary, correct? Let's say this is equation 1. Let's say this is equation 2. So therefore, since RHS is equal, equating the LHS, we have angle 1 plus angle 4 is equal to angle 4 plus angle 5. Cancel these two. Angle 1 is equal to angle 5, which is nothing but corresponding angles. So therefore, AB is parallel to CD by corresponding angles axiom. That's why you need to know the axioms, right? That's when you can prove such things. See, in exam, probably they won't ask you to prove the theorems, but they could ask some other things. Of course, they will ask you questions like prove that, like angle ROS is equal to half of some other angle, or prove that AB is parallel to CD. How do you prove that? Okay, so you need to know the theorems, axioms, and everything. Don't worry, it's not an overnight jadoo or magic, anything, nothing like that. It will take time. Meaning you need to daily practice. If you understand, that's the first most important thing, that you understand the given teachings and everything. Second is you regularly practice, and that will make your life much more easier. So you understood the proof. First we said that EB stands on line E, and I told that angle 1 plus angle 4 is equal to 180 degrees. How? Because it's a what? Linear pair. So let's take that as equation 1. Then we also said that angle 4 plus angle 5 is equal to 180 degrees because co-interior angles are supplementary. Then let's take this as equation 2. So angle 1 plus angle 4 is equal to angle 4 plus angle 5. How did I equate it? Because RHS is equal to each other. So angle 1 is equal, angle 1 plus angle 4 is equal to angle 4 plus angle 5. Now since angle 4 is common on both LHS and RHS, we are cancelling it out. So therefore, angle 1 is equal to angle 5. And of course, they are corresponding angles. By looking at the figure, you can tell that angle 1 and angle 5 are corresponding angle. So therefore, AB is parallel to CD by corresponding angles, axiom. So thus we have proved it. Easy. So this is theorem number 5. One last theorem, and we'll be done. Okay. Oopsies. So sorry. Into the last slide. Yeah. So what does theorem number 6 tell us? Lines which are parallel to each other, lines which are parallel to the same line, not parallel to each other, parallel to the same line, are parallel to each other. Now let's draw the figure. I know it's kind of messy. I'm trying my best, guys. Okay. So now we have here two parallel lines, transversal. Now let's take transversal T, line L, line L and N. And now a new thing comes in, another transversal. Ta-da, surprise. Okay, another transversal, not another transversal, another parallel line, which is M. So L, M, and N are three parallel lines. Let's take this to be angle 1, angle 2, angle 3, E. Let's take this point to be E, this point to be F, and this point to be G. So what are they saying? Lines which are parallel to the same line are also parallel to each other. Now look here. See. L, M, and N are three lines. L, M, and N are three lines such that L is parallel to N and M is parallel to N. Meaning this line L is parallel to N, and similarly this line M is parallel to this line N. Okay, this is a given information. Now what is the thing that is to be proven? If you look at the statement, they're saying that lines which are parallel to the same line, in this case L and M are parallel to N. That means that they are parallel to each other. That means L and M are parallel to each other. If L and M are parallel to N, that means L and M are parallel to each other. So to prove that L is parallel to M. Okay. Now in this case, guys, we have to do some construction, which I've already done for you. But anyways, I'm going to write down with the construction. Draw a transversal T cutting L, M, N at E, F, G respectively, which I've already done, but you have to write the construction. Now we need to prove that L is parallel to M, right? So let's see the proof for that. Now we know that since L is parallel to N and transversal T cuts them at E and G respectively. See, L is parallel to N and transversal T is cutting them at points E and points G respectively. So therefore angle 1 is equal to angle 3 because they're corresponding angles, correct? They're corresponding angles. Now again M is parallel to N and transversal T cuts them at F and G respectively. See, M and N are parallel to each other and transversal T cuts them at F and G respectively, so that angle 2 is equal to angle 3. Again, because they're corresponding angles. Now, let's take this to be equation 1 and equation 2. So from equation 2, can I say that angle 1, from equation 1 and 2, can I say that angle 1 is equal to angle 2? See, I know that angle 2 is equal to angle 3. So instead of angle 3 in the equation 1, can I write that, can I write 2 there? So that means angle 1 is equal to angle 2, right? From equation 1 and 2, from equation 1 and 2. Okay, angle 1 is equal to angle 2. But they are corresponding angles, correct? We know that they are, corresponding angles. So therefore, L and M are parallel to each other by corresponding angles axiom. Okay, by corresponding angles axiom. I know, I think 3-4 places we have used only corresponding angles axiom, but fortunately, at least you have to learn just by corresponding angles axiom. So therefore, L is parallel to M by corresponding angles axiom. So what did we first do? We first did that. We first wrote that angle 1 is equal to angle 3 because it's corresponding angles. Angle 2 is also equal to angle 3 because it's corresponding angles. We took each of them to be equation 1 and 2, and therefore we wrote that angle 1 is equal to angle 2. And anyways, angle 1 and 2 are corresponding angles. So therefore, L and M are parallel to each other by corresponding angles. Axiom thus proved. Okay, so therefore we have finished all our theorems. Hooray! All our axioms, theorems, parallel lines, transversal angles, blah blah blah. We've finished everything. Can you believe this? That's it, guys. That's it. And I thank you so much for staying so patient. Literally, I think it's almost 1 hour since I've been preaching to you. But it's all so important, guys. You need to understand it. I know it's quite a long intro to this chapter, but I'm sure it's worth it. And I hope you understand it. If you have any doubts, please let me know in the comments below. I will try my best to answer them and clarify your doubts. So that's it, guys. Thank you so much for watching. See you all in the next video. We'll be starting with exercise 6.2 in the next session. So make sure to see that session and develop your mathematics. Okay, so bye bye, guys. Bye for now. See you all. Till then, take care of yourselves. Bye, guys.